So let us learn another type of data structure in DSA, that is tree. Okay, so tree is also a data structure which is consisting of nodes. Okay, so similar to the nodes which is used in linked list but not the same, which are connected to each other using edges. Okay, so and they are arranged in the form of a hierarchy. Okay, so I have just underlined the most important key terms within a tree. So what is a node? So you see all these circles that I have drawn over here. So each circle represents a node. Okay, so the topmost node, you see the topmost element within the tree is called as the root node. Okay, because it doesn't have any parent. Okay, so what is a parent and a child? We'll get to know about that. And each node is connected with the help of edges. Okay, so you see one node connecting to the other node with the help of this line. Okay, so we call this line as an edge. All right, so this is a basic tree. You would have obviously you know what is a tree. You would have also seen in a real life example also. If I talk about a company, okay, so the topmost position that a person can hold is the CEO, and then comes its CTOs or anything. Then we come as a team lead, and then we have all the employees. Okay, so this is one of the example which we call that as a tree. Okay, so which forms a hierarchy. Okay, anything that has an hierarchy we can consider that as a tree. All right, so in terms of computer science, let us know what are the key features or key properties in a tree. You see that this is the topmost element or the CEO of the company, so we call that as a root node. Okay, so which doesn't have any parent, there is no nodes connecting to that, okay, from any other node, so that node is called as a root node. So then we have its children. Okay, so the children of number 1 is 3, 2, 4 and 5. Okay, so the numbers doesn't matter, it could be any kind of data inside that. Okay, so and again we see that its parent, these are all its children, and the parent of that is 1. Okay, and also we have subtrees also. Okay, so you see the subtree of this. Okay, so this is the subtree of that if we consider this. Okay, so when you talk about subtrees, the topmost element is 2. Okay, so I'm considering this as an example. So the 2 becomes the root node, and this becomes its children, and that becomes the parent, and this is the leaf node. Okay, so leaf node is something which does not have any children, so we call that as a leaf node. Okay, so these are some key properties that I have listed so that you just don't get confused. And we have the root node, the parent and the child, and then the height and the depth. Okay, so what is the height of the tree? From the root of the tree and goes all the way the longest distance between the the leaf node. Okay, so you see that this is the longest distance from 1, 4, 9 and 12. Okay, so it goes through 4 different nodes, whereas you see over here it goes through only 3 different nodes. Okay, so that's not the longest path, but this is the longest path. Okay, and we also call that as the height of the tree. So what is the depth of the tree? So for the depth of the tree, we need to provide the number of the node. Okay, let's say I want to find the depth of the node number 9. Okay, so what is the depth? 1, 4, 9. Okay, so we need to count the number of edges. So there are 2 edges, so the depth is 2. All right, so these are the key properties, and as I told, what is the subtree, and also there are other terminologies also as well. One is the edge and then the leaf. Okay, so if you'd like to take a screenshot, you can just take it. And this is all about a tree. So if I talk about what are the examples of a tree, you see the file system. Okay, you see in your computer. So if we consider this to be a folder, so each folder can have another folder, right? So this folder also can have another folder, and finally we can have the particular file. All right, so this is also like a file system is a good example of a tree. Okay, so all of this are implemented using tree data structure, but behind the scenes, but we don't actually know that. Okay, and also the DOM, this is one of the best examples in HTML if you're a web developer. So you see that if we starting from the head of the DOM tree and then goes all the way up to different nodes, so we call them different tags. Okay, so we nest tags inside tags, and like you would have seen that if you would have used HTML, so that also forms a tree, right? So usually when it comes to HTML, we call that as a DOM tree. Okay, so usually you might have heard such a term called DOM tree. So these are a few examples, and let me talk about what are the different types of tree. So one is we have the binary tree. So a binary tree is also a tree, but it only has 2 children. Okay, and that will be the parent itself. So if I talk about a binary tree, it can have only 2 children, so it cannot have another child, it cannot have 3 children, so that's not a binary tree. Okay, so and also this can have its own children which consists of multiple children. Okay, so it can only have at most 2 children. And the next type of tree is called as the binary search tree. Okay, so which is usually used for searching. Okay, so if I give you an example, so we have this again, this is also a binary tree, so it will have 2 children. Okay, so the condition here is the value of left, so we call this children as left and right. Okay, and the value of left, okay, so this can be a number like let's say 5. Okay, so the value of left should be less than the value of the parent, so let's say 3. Okay, so the value of right should be greater than the root and the left. Okay, so let's say 7. Okay, the right should be greater than the value of the root and also the value of the left. Okay, so this is basically used for searching an element within the tree, and the most efficient way of searching is through binary search tree. Okay, so we will also be implementing a binary search tree with the help of a code. Okay, so we'll be constructing that class of binary tree and how we can use it for efficient searching. All right, so this is all about trees. Okay, so let us learn more about trees. So there are other types of trees as well, like you call this as a trie and something called as heaps. Okay, so they are not much important in the context of DSA, and so we are only going to focus on binary tree and binary search trees. Okay, in this whole module. So let us understand more about binary trees and a binary search tree. So let us go ahead and start constructing a tree which looks something like this. Okay, so every tree has a particular node, right, which has 2 properties. One is the left and one is the right, and the value itself. Okay, so we can just go ahead and now create a class which has 3 properties. One is the value and then the left and the right. Okay, so I'm just going to call this tree node. Alright, so this is going to take in the constructor, and here this is initially going to take in the value itself for value of the node. Oops. And inside this we just want to initialize 3 properties. One is for the value which we are going to receive once we create an instance of this node, so we can just set that to the value that we are receiving, and this dot left equal to null initially, and the same for right. So initially they will be null as long as we set a property or a node linking to this left or right. Okay, so the left is this and this is the right. So now I'm going to create all of these nodes, and then later using these left and right properties I'm going to connect them. Okay, so let's get the first step done. So I'm going to set a to new tree node and then pass in a as a string, and then do the same for all these other values. Okay, so I'm just going to duplicate this and then replace this with b and do the same for the others. So now we have all the nodes, so we can just go ahead and connect them. So we can just set a dot left, since this is an instance of this tree node, so it has these 2 properties, right, along with the value left and right. So we can just set that to pointing to b. Okay, so like this, and we can set now a dot right to c. Okay, very simple. You can just try this if you want, and let's now do the same for b. So b has left as d and right as e, so we can say b dot left and set that to d, and b dot right and set that to e. All right, and finally we can set c dot right to f. Okay, so our tree is now constructed, so we can just now go ahead and console log the value a, and once I save this and open my terminal where this file is actually running, and we see that we have an instance of this tree node where the value is a that we just set, and we have left set to another tree node that is b. Okay, so this b over here, and this b in turn has another 2 properties, that is left and right, which are mapped to D and E. Okay, so this keeps on going recursively. So you can just imagine, and right also is a tree node which has a value of C over here, and the left is null. You see that there's no element over here, and right has a value of F as you see over here. Okay, so I hope this is clear to you. So we have just implemented a binary tree which has just two values, left and right. If you want to like store more values, you can just set this to an array of children, and then we can just give an ID for every children that we have, and then we can map in, or we can just set more children for that particular node, and then we can just keep on doing that. Okay, so just to keep this simple, I've just constructed a simple binary tree. We can also do this recursively if you want, instead of like creating so many tree nodes. So we can just apply a function which calls it recursively by creating multiple tree nodes, and it will construct this kind of a structure. Okay, so yeah, this is all for this video. If you have any questions related to trees, you can let me know in the comments down below. So thank you so much for watching. I'll see you guys in the next video.